Let's remind a bit about current and electricity and then do some questions, some MCQ questions that will be very useful for you. Now, when solving MCQ questions, you should understand about potential dividing. Now, you know the equation V equals IR. You can use this and understand certain facts. Now, when I have resistance R1 and resistance R2 and potential difference of V here, if a current I flows through R1 and R2, we can say potential difference across R1 is V1, potential difference across R2 is V2, then we can say V1 is equal to what? I times R1, V2 is equal to what? I times R2. If we divide both these equations, say equation 1, equation 2, if we divide both these equations, we get V1 divided by V2 is equal to R1 divided by R2. I hope it's clear. We can highlight this and keep, right? Next one is a quick revision. Now, I can say this. I have a total potential difference V across resistances R1 plus R2 in total. So across R1 and R2, I have potential difference of V. Then how much is there across what? R1, for example. Then we can get V1. I have a potential difference of V, once again, across R1 plus R2. How much do I have across R2? Then we get V2. So this is the principle of potential dividing. Now actually we can see something interesting here. What is V divided by R1 plus R2? That is the current I. So I can replace this with what? I. Therefore you can get the equation what? V1 is equal to I times R1. The same thing. Right. I'll remind more facts later. So let's first discuss this question. Look at 2009. Question number 39. You can see they're giving you a diagram, 100 ohms, and then we have 10 volts. Internal resistance of the battery here is 0, and then we have 100 ohms back again, and it is, and then we have 150 ohms. Please try these along with me. And then we have here 5 volts. Here R is equal to 0. And here we go. Right. So they're asking this question. In the circuit shown in the diagram, the current through the 150 ohm resistor is. They're asking the current through the 150 ohm resistor. How can you find the current through the 150 ohm resistor? Current through the 150 ohm resistor. Let me think now. It's very easy if you can use this grounding technique. I can ground one point. Any point you like, you can ground. So for example, I'm going to ground this point. Grounding this point means I'm going to make the potential of this point equal to what? 0. Then along this line, the potential is going to be 0. Here the potential is going to be 0. 0, 0, 0, entire thing 0. What's the problem here? Here I have normally plus 5. Can you see that? Now 5 volts. Can you see this battery? The 5 volt battery. So but the problem is this. Here I have 5 volts. Then I have to put 0 also because I have earthed this. Therefore this becomes minus 5. Exactly. Because I have earthed this. Along this y the same potential continues. If I make the 0 here, this has to be minus 5 because I would have the 5 volts potential difference. Then minus 5 continues along this line. Minus 5 continues along this line. Then I have minus 5 continuously. I have minus 5. So here we go, minus 5. And now, as I've earthed this point, what can I say? I've earthed this point. What point? This point I've earthed. Then if this is 0 here, this should be plus 10. So this is plus 10. So plus 10 continues like so. Forever it continues like this. So it continues up to this point. Right. So here I have what? Plus 10. Now can you see, we can find the potential difference across 150 ohms. Yeah, what's that equal to? 15 volts, because 10 minus 5 volts gives you the total potential difference across 150 ohms. So V equals IR. So what's the total potential difference across 150 ohms? 10 minus 5 volts. Therefore, that's equal to the current I that we don't know times the resistance 150 ohms. Then we get 15 plus 15 divided by 150. Therefore, the current is what? 0.1 amperes. That's how we do this question. So you can note these particular points when you're solving these kind of questions. So understanding that you can ground at a certain point, and then how you can get potentials at other points. Now, for example, I grounded this terminal of the battery, and then this becomes plus 10. So the plus 10 continues throughout, and then it's 0 here, and therefore I have to have the potential difference of 5 volts. Therefore, if 0 here, it should be minus 5. I hope you understood this. Some more facts about current. Some children find it very difficult, but actually current is a very easy lesson. We can just discuss that very soon. 2 days of work, that's enough. And also, you have certain doubts about power. So if you want to understand about power, now power, I'm just giving short notes. Power is equal to I squared R. Have you heard of this equation? Yeah. But we know P is equal to what? VI. Power is also equal to what? V times I. I know V equals what? IR. If I substitute IR instead of V here, I get I squared R. Now again, instead of I can substitute what? V divided by R. I'm going to put V divided by R instead of I here. And I get V times V divided by R, that's equal to V squared over what? R. So now understanding about certain points of applying this, it's like this. Now for example, let's say I have resistances R and 2R, and the current across them is I. I have no idea about the potentials or the potential differences across what? R and 2R, no idea, suppose. Now, but I know that the same current flows through them. Then we can use what equation? P is equal to what? I squared R. So can we say that when I double the resistance, the power dissipated across that resistance doubles, because I is the same across them, therefore power is proportional to what? Resistance. If I double the resistance, the power dissipated across that resistance, doubles. So double. It's clear. Now, another example is when we have the same potential difference across resistors. That is, if I have here R, and here 2R, potential difference is V. But I have no idea about the current. Suppose I have no idea about the current. Then, just imagine, I don't have any idea about the current. But then I can use the equation P is equal to what? V squared over R. Can you see that the potential difference is the same for both 2R and R? Then can you see that if the potential difference is the same, V squared is the same for both. Therefore, power is inversely proportional to what? 1 over R. That means if I double the resistance, that means I multiply this by 2, I get what? Half the power. So if the power of this one is P, the power of this one is what? P over 2. I hope it's clear. So facts like this can be done very soon. Very easy, this topic. I'm not mentioning everything, just a quick revision, not even a revision actually, right? Okay. Now let's look at a certain diagram that they are given in the 49th question of 2009. Look at that diagram carefully. They have given you an EMF of value E, and They say that there is no internal resistance, therefore R is going to be 0. And we can see that they have earthed one point. And then, sorry for spending a lot of time here for drawing diagrams. You can draw along with me if you can, it will save time. And we have R here. And here we have R, which is variable. Simple R, which is variable. And then I have point A here, and here what? Point B. Here resistance R. And they have connected terminals like this, like A is connected like so. And then V0 for B. So they're asking the variation of the potential difference V0 between points A and B with R is best represented by. Potential difference V0 between points A and B with R is best represented by. What do you say? What do you think? Now can we see that when I make simple R equal to R, I get the same potential at this point A, which is equal to potential at point A. Why? If I have here R, capital R, then simple R is equal to capital R. Now I can earth this point, therefore the entire thing here is what? 0. 0, 0, 0. There we go. As I've earthed here, I can say that the entire thing here is E. All the points have what? E. So here, two equal resistors, therefore this should be what? E upon 2. You understand that? E was there between 2R, how much equals R? E upon 2. So we have E upon 2, a potential for what? Point A. Now let's see the potential at what? Point B. This line continues, the same potential line continues, then he says what? E, the techniques. Then if E is present between 2R, how much equals R? Again E upon 2. Therefore, can you see that when simple R is equal to R, the value of V0, what is V0? Potential difference between the points A and B should be what? 0. Can you see that? And in graphs, for example, fourth one is not mentioned. And in other graphs they are mentioned, right? So you can eliminate the fourth answer. But what else can we say? If I make simple R equal to 0, what will happen? If I make simple R equal to 0, what will happen? Just think a bit. Yep. Does this change? No, this doesn't change. This is always what? E upon 2. But if I make this 0, what will happen? If I make this 0, it's like this straight conducting wire. Then E continues. Can you see that? This E continues. Here was E, here was E. E continues. Therefore, E here and E upon 2 here. Can you see that? E here and E upon 2 here. Therefore, when R goes to 0, now, can you see that? So they are asking, when R goes to 0, what will happen? What's the potential difference now? VB minus what? VA. That's equal to what? E minus what? E over 2. That is equal to what? E over 2 plus E over 2. So VB minus VA is equal to E over 2. Can you see that? Okay. Now let's do something like this. What will happen when R goes to infinity? When R goes to what? Infinity. That means there's infinite resistance. It's like then what? It's like this. Infinite resistance means like something like this. If it is infinite resistance, things become interesting. What's going to happen then? Yeah, then what can we say? When that happens, you can say that 0 exists along this line. Therefore, it's going to be 0 continuously. Because infinite resistance means like you don't have a connection, that kind of feeling. Therefore, this is going to be what? E and E upon 2 is there. Therefore, VB is going to be what? 0. Can you see that? VB is going to be 0. Point B. VB is going to be 0. But VA is going to be still E upon 2. Therefore, we can say VB minus VA is going to be what? Now, what is VB? 0. What is VA? E upon 2. Therefore, we get VB minus VA minus E upon 2. Therefore, the answer that matches with this is the first one. I hope it's clear.